Welcome to Vision Driven with Resin Architecture, the podcast where we dive deep into the world of architecture, development, and construction. I'm your host, Greg Croft, and my co-host is Jamie Moulton, and we are thrilled to have you join us on this journey of learning, inspiration, and insight.
When you talk about real estate, I would always recommend that you go into it with the exit in mind.
Advice I'd give somebody that's presenting their case or pitching their loan to a bank is just to be really well prepared.
Whether you're dreaming of building a space for your business or simply curious about the fascinating world of architecture and development, join us on this exciting adventure as we unlock the secrets to successful projects and empower you to turn your vision into reality.
All right, today we're gonna have Markell Bateman with Frost Engineering. Markell is a structural engineer, and we're excited to have you. Can you tell us a little bit about your background and why you decided to get into structural engineering?
Yeah, so that's a good question. So I grew up in a farm in Wyoming, and there was always like problems to solve and things to figure out. And my brain was always pretty busy, kind of a dreamer brain. And then my older brother went into engineering, and so I decided to go into engineering. I took some classes for a semester, and I thought it was interesting, but then I quickly said, I want to go into business. And so I took some business classes for a semester, and then I had a break for a while, and then I decided I wanted to go into history and become a history professor. And then my older brother was like, you know what? You're going to make less money in history as a history professor than an instructional engineer. So I went back and started focusing in structural engineering and quickly went through school and kind of worked in the construction field while I went to school. But I guess it's probably the biggest thing I want to do is solving problems. I enjoy solving problems and figuring things out. And so it kind of gave me an avenue to solve problems and look at things differently.
So why structural engineering instead of solving problems in chemical or mechanical or electrical engineering?
That's a good question because I still think I sit through a lot of meetings where we deal with mechanical engineers and structural engineers, and I've set meetings with you guys as well. And I probably say a little bit too much because I know the systems. So I think you can still do those type of systems and have a background in them. Not necessarily do the system, but have like a background of what you're talking about, like different mechanical systems, and then you can do a better job designing structural. So I really probably, because I was following my older brother and what he did, and I have a younger brother who was in structural as well, so we all got convinced to do it. But I still apply the same problem-solving skills that I learned in structural engineering for other avenues in my life. And so as long as I don't stop and look at too many structures when I'm at dinner or driving across the bridge, my wife's okay with that.
In the construction world, what type of role does a structural engineer play? I mean, it probably sounds obvious to most people, but why do we need a structural engineer?
So there's different type of building types. So like a lot of people in Idaho area, they don't do tract homes where we design structural engineering. They've done the same thing over and over and it's worked. And so they do it, and they've had any failure problems, they revise it. In bigger cities in Las Vegas or California, they make everything be engineered. So Idaho is a little hybrid. Most of the stuff, like smaller projects, do not be engineered. I feel like on the development side that we can provide a value and get the costs down and talk about systems. And we can kind of meet with the developer up front, kind of find out what their needs are and go through systems and say, okay, what do you want to see in your project? And look for ways to save money and make things more efficient, whether it's mechanical systems, penetration of structural beams, or rerouting the framing for the plumbing lines or whatever we need to do. If we know that up front, working together as a team, we can make things, I think, more efficient.
Markell, are you aware of any mistaken assumptions that people have about structural engineering?
Probably the biggest mistaken assumption is that we're all geeks. So I try to have some communication skills. No, I think most of us in the structural engineering atmosphere, especially in smaller communities, are pretty communicative and talk and interact with people pretty well. I think sometimes structural engineers get the appeal that if a structural engineer touches, it's over design, and all depends on what we're doing. I mean, if you're doing a bigger project, my goal is to always make it very efficient and save money versus just make a quick solution. So I guess there's kind of two concepts there. One, is our perception of nerds or geeks, and the other one is that we do over design things.
One of the, I guess, the next question that I would have is like, when should we involve you as a structural engineer in our projects? And this is kind of a leading question, but I think it's an important one.
I think it's all how big the project is. Like we'll get projects all the time that are smaller jobs, and the city requires that they have certain engineering. And sometimes it's better that the city reviews that, and then we get in and do a minimal stuff. But the bigger the project is, I think the more money we save, the earlier we're involved. Whether it's like, hey, if you change your wall lining at the lower level, we can not have to cantilever it as much, or revise certain things, or save on foundations. And so, again, probably the scope of the work, the bigger that is, I think the more important you're involved in. Or if there's a lot of repetition, you want to make sure there's involvement early and often so you can get that value saved. I just had a conversation with a contractor today, and he was telling me about the difference in plywood prices. It can be $13 at BMC or $11 right now at Home Depot. And so cost is a big deal. I mean, and if in a project that has 28 or 280 units, and you increase the same thing over and over and put plywood where we don't need plywood, it can drive the cost of the project of hundreds of thousands of dollars, or even $500,000. It all depends on the systems you choose.
Yeah, a lot of our bigger projects we like to pull. I mean, we do what's called concept design, but we have pulled you in on concept design earlier in situations where we felt like, hey, you know what? There's a lot of questions, and if we pick the right system earlier, it's going to save the client ultimately more money, both from a design side and then also from the construction side. And so, yeah, kind of was the leading question, but I feel like, again, super important to recognize both the benefit up front, and then, that's probably not where it's not where you're doing the majority of your work, but it does lead to a lot better results or end result there.
Well, and I think that there's different involvement in clients. We have some clients that are very engaged and some clients that aren't engaged. And I believe the design build system is often the best if you have everybody has a great working relationship and you have a good relationship with the contractor, because we can get some pricing up front. But if the client sees that we were trying to have their best interest involved in the meetings at early phase, I think they feel like the value in their project is efficient and effective. And so they're more bought into the project when construction costs may go up because of unknown reasons like we've had with COVID.
Tell us what advice you'd give to someone who's working with a structural engineer for the first time.
That's a good question. I think just have an open dialogue with them and just let them share, and you listen. You may have questions, because a lot of terminology, like I try to, when I communicate to someone who has not worked as a structural engineer, I try to communicate in a manner that's at their level of understanding. I mean, we can talk about shear and moment and whatever, but I try to simplify it and like, hey, like I often use spaghetti noodle as an explanation. I think you've heard that before, Greg, where like, hey, your beam is much like a spaghetti noodle. The more spaghetti noodles you have, the stronger it is. And people can understand that a little better. So I think just probably asking good questions and saying, or not being afraid to ask a question, that's probably better phrased, is ask questions. If you don't understand it, just let them explain it, because the more you understand as a developer or owner, the better you are. Now, time is valuable, and it does cost if you're on an hourly job, but sometimes just asking some simple questions like, what happens if I do this, or just a better clarification so they can understand better.
I was doing some research on that today, actually, for our office, and how architects can sometimes use jargon also. And the point of any communication is to convey an idea, and how important it is to simplify those concepts, especially for somebody who's new to design. That's
right. That's a great point.
I guess on that communication piece, how do you, so a lot of, we have a client, and then it goes to the architect, and then it goes to you. How do you ensure that you're getting the vision of like what the client's after, even though the architect is kind of directing you on something? How do you ensure that you've got kind of the full picture?
That's a challenging one, because sometimes I wish I could circumvent the architect and go directly to the developer and just being honest, and say, hey, do you really want to do this? Because we do a lot of custom homes, and so there's things we could do to cheapen it up. and often our comments to the architect don't get to the developer, and I don't mean that all bad, or the homeowner, and so that's a hard one because I can only communicate so much. If the developer is part of the team meetings, like we've done with you guys many times, then we can communicate to them directly, or we can pass on different things. We often like to do, like you said earlier, schematic plans. And so we'll do like a schematic layout that's very economical, show beam layout, show design, bring up any questions. And we hope that gets to the owners or the developers so they can do pricing and say, here's your consequences and here's some things. And if they can see that, they may say, wait a second, I may want to pull a wall in or shift a column so it's just a little cleaner to frame. And then with the hopes that a contractor just doesn't bid it per square foot price, what they're typically doing, but sees that the structure has been simplified, and then that way that becomes more economical.
I know that I've gotten like red line sets from you guys because we'll sometimes, even if you're not on the project, we'll be like, okay, this project is coming to you. Here's a schematic set, mark it up, and it'll say things like, hey, if you can give us 2 feet of wall here, then we can actually shear up this, and so we reduce our window sizes a little bit, but ultimately it's like, yeah, it still has these picturesque views that you're trying to hit. Or I think I have had the comments too where it's like, hey, if you can shift this a little bit, then.
Well, and then the architect will often go back to the owner and say, can we shift this and say this? And they'll say, no, we want this look. We're willing to pay the money for it. We're currently trying to push a project your way that we're the kind of the lead design of industrial building. And then we're like, okay, we're laying the whole thing out and then trying to shift it your way, which is kind of different than often done in the industry. But there can be a value there as well, because it's mainly a structural thing. And then we have to work on exiting and fire rating assemblies. And so a kind of a different approach, but the same thing is the owner's got to get your feedback, and they can't have us filter it.
Right. Yeah. No, that's probably a similar approach where it's like, hey, here's the red line sets, like in terms of what life safety issues that we see, and so, yeah.
Well, Markell, you have good experience as a structural engineer. What are some of the ways that structural engineering has changed over the course of your career?
So I've been in the instructional engineering industry for 25 years. And I would say it's actually gotten more difficult versus easier. And maybe it's because I manage more than I used to. But I think that the technology has increased the expectation of clients saying this should be faster because you have technology. But we also do larger volumes of projects. And so we have to mix those in. And so I think that's one of the more challenging things that have changed is just the expectations. We want it faster. Let's get it done quicker. This saves us money. We've also seen the last few years since 2020 where the increase of construction costs have really kind of hampered development. And so then just come back and have to do redesigns quickly when you're already very busy, but trying to keep an owner and developer happy. And many people don't realize that when you book out, just like you guys, you're 2 to 3 months out from work and you want to keep this client happy, but they need a redesign because they're out there pouring foundation. They have to have the framing change because the cost of construction's increased. So that has made it a challenge, the fluctuating markets currently to do it. But overall, I mean, it's still good. It's still progressing and things are getting better.
Yeah. It's you say the calculations that you guys have to do is more frequent, but on top of that, the number of drawings that we produce is ridiculously high. I was in Washington, D.C. this year, in the Capitol building that has all that ornate detail. It's like today would be hundreds and hundreds of sheets, probably thousands of sheets. And back then it was like, here's the sketch and run with it. And even as we pull up historic drawings here in Idaho Falls, it's like, hey, a lot of these buildings only had 7-8 sheets total, at least from an architectural standpoint. And so the number of sheets that are being produced is ridiculous, but that's what the jurisdictions are requiring, and that's what it takes to get the intent out there. Otherwise, a contractor can really, there's nothing to hold their hand through the process because we don't build like we used to, and so to get the level of quality that we want, we have to document more.
Well, I also think the liability's increased. And that's also, I mean, because today I was working on helping someone out with a remodel of a house, and we had a little deck on, and we are more sheets for adding a little deck on than they had for the architectural structural drawings. It was 4 sheets, and I think we're like 10 when it's all said and done. And just to communicate intent, like you said, but also more and more people don't want to see a cracked sheetrock, where before they were okay with cracked sheetrock, or they're okay with figuring out certain finishes, and they want it figured out for them, and so then they can apply it. And the contractor doesn't want to do it, because then he's held liable for doing something with no communication.
How do you, I guess, following off of Jamie's question about what you've seen in the past, how do you feel like, what's the future of structural engineering? What do you see 5 to 10 years out?
Well, I've thought about that as we continue to strive to grow. And I wonder if we're growing, if we have to kind of adapt. I often think about Sears Roebuck and how they used to control all the markets, and now they're pretty much gone. Yeah. And so more and more as a business or in our careers, we have to adapt or we die. We don't know what business is going to take us over. And so I do feel there's a lot of changes coming, and the process to engineer will become faster. With AI, artificial intelligence, right? I always just call it AI. I think there's some opportunities to increase speed and accuracy, and then have someone who checks it. But they have to have a very thorough and checking process to mix that up. But I think there's things you can do where they can pull in standard details and in seconds tweak the slopes, the miscellaneous items that would take you 30 minutes to an hour to draw up, and you can quickly just tweak by having a standard and say, here's my slope, here's my overhang distance, and it automatically just generates everything. So I see that next 5 or 10 years where it'll become faster, but there is a huge demand right now for engineers. And so maybe that helps lift the demand, engineers and architects as well. It's hard to hire them. So I think it'll help lift the demand, but also increase the expectation of precision, that there's no mistakes and you'll be held liable for anything that's a mistake or a cost break.
Do you feel like, I guess on that front, with the 2008, 2009 kind of crash, there's like a lot of architects and probably a lot of engineers as well that there wasn't jobs. And so we find, at least in our industry, and I'm assuming this is the same for you guys, where it's like at this point, anybody who graduated, 10 to 15 years ago doesn't really exist. There's not a lot of them. And so from a project management and experience level, you have these weird kind of these ups and downs of like experience levels. And that's been the concern that I've had with AI is how do you get the experience when somebody's jumping from, I don't need to do details anymore. Like there's some of these things that they start to not do. And then is there a knowledge gap of, I don't actually know what I'm checking anymore?
Well, and I think that goes back to 2D versus 3D, right? When people all drew in 2D, you had to think in 3D to solve the problem. Now the 3D is drawn for you, and so it's sometimes simpler, and you can't see the problem because you're so used to looking at 3D that you don't think outside the box. And so and that's one thing I think I'm grateful for, that I've had the 2D experience and had to, in my mind, put it in a 3D realm. So now when I look at drawings that are 2D without the model, I can see beyond the 2D without having the model, when our guys in our office who've all seen everything in 3D can't visualize what it can be.
Okay.
Does that make sense?
So the gap will, the gap kind of exists right now from a 2D to a 3D perspective, and now we're going to go from a 3D to an AI perspective where some of that work is just being generated. And yeah, I guess you're saying that the gap is going to continue to kind of grow a little bit.
And I think that's where it's really crucial in developing the next generation is we as older, experienced, hopefully maybe wiser, share our knowledge and help develop the next generation. That's what I believe is one of the most critical things I do. Is I'm a teacher, and I develop and I create better systems, and I help the younger generation see the gaps that are missing, like you said, and say, hey, something to consider here, and something to recognize here on using the 2D, 3D or elements, you can catch these things in 2D without seeing the 3D.
That's one of Resin's core values also, is being dedicated to teaching and learning both in the office and with this podcast for our clients also. So tell me a little bit about how you balance the rigorous demands of engineering laws, of physics, and the way the world works with what a client wants.
So my goal is always to provide a great service, and sometimes that's hard because sometimes, for example, if the government, the city jurisdiction or the county jurisdiction requires engineering, often we have to put in things more in the drawings to meet the current code than what they typically are getting used to. And so often we'll get pushback from clients saying, hey, I haven't done that before. And I was like, I can't change that because this is what the jurisdiction requires now, that you do the full engineering, versus before it was more a prescriptive method. So often what we'll try to do there is like, hey, here's the situation. You brought a project in. Typically you haven't had to do engineering, but now they're requiring engineering. So we'll say, maybe submit it to the building department and see what they kick back, and we'll only engineer the parts or the pieces that they were required, so we don't have to touch the whole project. And so we try to limit our liability by saying this is the scope of work we're providing, but also not increase the cost of the project.
As a final takeaway, our last question is always based on your experience. What's the one piece of advice that you would give to a client that is looking to build a building?
If it kind of going back to what we talked before, if it's a really large building, it's important that we, again, I think, bring great value up front. And a bigger scope of project is get them a structural engineer involved earlier versus later. Even if it's minimal fee, just make some decisions and you can save quite a bit on the structure and make things stack a little better, a little cleaner, and still get the architectural appeal that you want. So I think that, but on smaller projects, maybe not. Maybe it's just, hey, there's minimal things we want you to do. But engineering, it can be very, very valuable. And I often struggle where more and more the local jurisdictions are forcing engineering upon everybody. I understand the why, to create a quality product. But we as engineers want to make sure we want to feel like people appreciate us versus feeling forced to use us. And so I think maybe to reiterate the question, why we want to do or why do you want to get us involved earlier? What do we bring for the client? Is we can provide opportunities, help people think differently, sit down with you, talk to you about it, give you options, and then you make a decision what you want to do. I much prefer that versus them being compelled to use us.
Awesome. Well, thank you for your time today.
Thanks, Markell.
Oh yeah, thank you for the opportunity.
And that wraps up another enlightening episode of Vision Driven. We hope you enjoyed our conversation and gained valuable insights into the world of architecture, development, and construction. And don't forget to leave us a review. Your feedback helps us grow and improve our content, and it also helps others discover the podcast.
If you have any questions, suggestions for future topics, or if there's a specific guest you'd like us to feature, please reach out to us through our website, resinarchitecture.com, or connect with us on social media at Resin Architecture. We value your input and would love to hear from you.